Today we're going to be testing plus minus 45 tension. Again, this is the strain gauges that we'll be using. So this is 125 UT, or the longer name here down the bottom, CEA 125 UT 350. And we have the important information that we need. Trying to get it in focus here, sorry. I don't know if you guys can see that or not. Right, so up in this box here, and I'll read it off to you guys here in case you guys can't see it. So we have two grids, if you remember. This is what the strain gauge looks like. The biaxial strain gauge is what we use for most of our tension tests. And again, it's bad lighting, I know, I'm sorry for that, and I don't know how well it's focusing, but we have two little grids in here, right? So both of them have two different directions that they're measuring, I guess you could say, and they're perpendicular to each other. So one is a 0 and one is a 90, or a 0 to a 90 to each other. You could really put it on this way or this way. Either way, you're getting the same information. So each one of those grids, though, has a specific set of numbers, right? Oh, sorry about that. So grid 1, for instance, has a gauge factor of 2.135 and a transverse sensitivity of 1.1. Grid 2 has a gauge factor of 2.16 and a transverse sensitivity of 0.8. And as always, all the resistance values we use for our strain gauges that we do here are all the 350 ohms. With that out of the way, let's take a look at what the actual samples look like. So this is a sample without a strain gauge on it, right? So you see this little space here. So before we put on strain gauges, you have to do surface preparation. So what you see here is I've already done it already. So I've kind of blocked out this area here because I know this is where the strain gauge is going. So what I'll do is I'll sand that down. Now I've already cleaned it up and everything, so there's no residue left over there. Now you can see in the background here, all the rest of the gauges, all the rest of the samples are strain gauged. Just a close-up of what that will look like. So again, that's our biaxial strain gauge, right? And again, this you can kind of see a little bit better here. The two grids, right, one on top of each other. We have our end tabs here. You see these end tabs are beveled. So when we do tension tests, we always bevel our end tabs. Beveling means this little taper that you see there, right? See a little bit better there. Okay. There's the back of the strain gauge. So the wires, you have this piece of tape here. So we always want to support our wires. If I didn't have this piece of tape here, these wires would just stick out straight, right? And there's a little bit of weight to these wires. It doesn't seem like much, but with this sort of length, I mean, this probably isn't a lot, but this tape helps sort of it's sort of like a shock absorber as well, right? If I pull on this by mistake, it's really not going to do much, right? But if I didn't have that piece of tape there, and this wire was just sticking straight out, if I try to tug on it the way I did, I'd completely just rip it off. A lot of times when you're handling strain gauges, you don't even realize you might snag onto other things. So it's not like you're purposely trying to pull on them, and that's why we put the tape on. It's just because it can snag. And when we're tying the wires together over on the frame, tying them together, you'll be pulling on them a lot. So if you're pulling on them, again, you want to make sure that that is supported, right? Using that little tape as that shock absorber, right? Here we are at our setup for the tension test, the plus minus 45 tension test. Most tension tests look very similar. When we say plus minus 45 or 90 or 0, that really has to do with the orientation of the sample that we're testing. But the actual fixture and how the fixture looks is typically the same. We might change around load cells. In this case, we're using a 50 kilonewton load cell. The two computers you see here, the one computer here, this is our Blue Hill software. This is the one that controls the instrument. This over here, this is our System 5000 software. And this is the computer that will be acquiring the strain data from the strain gauge. And just briefly, we have our load cell. This is our upper grip. And this is our lower grip. So now we're going to load the sample into the grips. All right, so now we're going to go ahead and put the sample into the tension test fixture. There's a few things we have to consider first, right? So these grips are a certain distance apart. Now, how did I get to that? Well, that's the same distance as in between your end tabs, right? We talked about gauge length. So the gauge length is basically the distance in between your two end tabs. Now that same distance should be the same distance as your grips, so grip distance. So that's how we know kind of where the grips need to be. And then we just want to, when we put it in there, you just make sure that you're putting it in evenly so that the top and the bottom are getting basically the same real estate. But then the question is, how far back do we put this into the fixture? Because there's, well, there is 2 inches of depth here. And we don't want to press it all the way back. And it's kind of hard to see from this perspective, but this is all the way back. And then this is more towards the middle. And then this would be towards the front. Where are we supposed to position it? We're supposed to position it in the center. How do we get to the center? We use our trusty spacer, right? This spacer is 1/2 inch. We said this has 2 inches of depth. And the sample itself is 1 inch. So that's where I'm using the 1/2 inch spacer because with 1 inch sample, I have 1/2 inch on both sides, right? So let me go ahead and put that spacer. I'm going to start from the bottom. And I just firmly press the sample back against the spacer. And again, the spacer is backed up against the back of the grips. Okay, now once I'm happy with everything, I go ahead and I will start to tighten the bottom. Now these are all left-handed threads. So in this case, it's righty-loosey, lefty-tighty. So once I have the bottom snug, I'm not really like cranking too hard, I can let go. Now it's held in place. So now what that allows me to do then is to go ahead and tighten the top. Okay, so I kind of just tighten the top grip snugly as well. We don't crank down yet on both grips because we need to take out the spacer. So to take out the spacer, I'll loosen the bottom up again, just enough to take out that spacer. Now, as we start to tighten, it's going to start loading the sample a little bit. Typically, the stiffer the material you're working with, the more load you're going to get on the fixture. So what you have to do then is you use something called Specimen Protect. It's a button on the console or on the software. And what you do is you give it a value. In this case, I gave it 1 pound. And it literally protects the specimen, being that it'll adjust the displacement if your load is starting to go past, anywhere past that 1 pound, right? So if you have 20, 30 pounds on it, then we need to relieve it with moving the displacement manually typically, but with the Specimen Protect, it actually automatically does it for us, which is really nice. All right, so let's go ahead and start cranking. Okay, so we should be good there. And next we need to attach our wires. Now, because both grids are very different, meaning one is in the 0 direction, one is in the 90, the grids on the strain gauges that we're using. Channel 1 and channel 2 in the software have then, we've set them up specifically for that particular grid. So channel 1, I set up to always basically be grid 1, or I mark it with this little piece of tape, or I call it a flag. So I know 1 always goes on to where the flag is. And then 2, when I wire it up, is always grid number 2. So that one goes to the remaining one. All right. So wires are all ready to go. We're not changing anything else on the physical test setup. The only thing left to do now is all the software. And again, that's the System 5000 to measure the strain gauge via the wires. And the Blue Hill software, again, which is controlling the actual test. Right, so the test has started. Now, this test is just under 20 minutes. It's on the longer side of the mechanical test that we do. But when I'm testing, and I'm here doing it, even though I know I have a test that will last 20 minutes, I have to keep an eye on the test. You want to take notes, anything you hear, anything visually that happens. Those are the things that you want to report. So it's a good idea to watch, test, and not just go and do something else. so that is obviously the end of the test. You can see the failure there. Okay, so I'm just gonna leave you guys with a final shot of the failed samples that we tested.